Welcome to the course on R programming. Till now we have learned how to work with the various data structures of R programming. And we have learned that R is very much useful for the purpose of data analysis. Like we are going to take a customer data and we are going to analyze that data in different statistical values, statistical methods, and as well as in graphical format. In this session, we are going to see one example. That is, we are going to load the customer data and we are going to see, we are going to analyze that data using various graphs and plots. Let us see that. So, before starting the project, we have to check that what is our working directory. And in previous classes, we have learned that getWD stands for the get working directory. Get working directory. This is going to give us that where the R software is installed. So in our case, in my case, it is in C drive. Most of the cases it's going to be here only. So we have to change this working directory to our own directory where our data is available. For this one, we are going to use a function called the setWD, set working directory. So using this set working directory, we are going to set our working directory. In my case here, I have set it to F drive and so folder. So in this folder, my data is available. My data file, that is in the form of a CSV file, it is available here. So once if I set my working directory, then I can load my data. See, this is my data. So it's my customer data. You can see this mar underscore customers is my file name. So in a mar, what are the different types of customers have come? We have sampled and we wanted to do the analysis. So we have customer ID as a column, gender as a column, and age group we wanted to analyze, and what are the annual incomes of each customer. We have collected that one. What is the spending score? That score is from 1 to 100. If that person spends a lot, we are going to give more than 90. If the person spends little, we are going to give 10, 20, like that. So this value varies from 1 to 100. You can see that this is value 6. In the sense, that person or that customer spends little bit. Whereas this person, 99, his spending score is high. Okay. And we are not discussing that how we are going to compute this spending score. Just our duty is that the data is there and we wanted to take that data and wanted to analyze that data. Analyzing in the sense, getting some insights, means some meaningful information we wanted to extract out of this data. By seeing like this, 1,000 records or 1 lakh records or 1 crore records, we may not get any useful thing. But if we convert this into graphs and some statistical values, then it is possible to understand something about this data. Let us see how we are going to do that. So now the next step is that loading the data. How we are going to load that data? To load that, we have already learned that we have a function called the read.csv. So we have a function called the read.csv, and many a times I told you CSV stands for comma separated value. This is the file format. So as I told you, our file name is mar_customers.csv. Okay. And as I have set my working directory, I need not to give the full path of this file. If I have not selected the path, then I definitely have to give this entire path. If I have not set my working directory, okay, that you have to remember. So after loading this data, the first step what I have done is I wanted to check the column names. With the help of this names function, I have checked what are the column names we have. That's the customer ID, we have gender, age, and annual income in thousands, and spending score. Like we have 5 column names. Okay. So these 5 column names we have, that we can see with the help of that names function. Then we have another function called the str. That str stands for the structure. This structure function gives us the entire structure of our data or file. So here if you observe, it shows that what is the type of this thing. And you might have remember that when we load the data, that data is going to be converted to a data frame. A data frame. When we load the CSV file into our environment, that is going to be represented in the form of a data frame. So here is the thing. So if you see this structure, the first point it is going to show that what is its type. Its type is data frame. And it is showing 200 observations. Means how many records are available in that file. So 200 records. In the sense we are analyzing the 200 customers data. And how many variables we have? 5 variables we have. Those are this one: customer ID, gender, age, and annual income, and spending score. And come to this data types. Customer ID is integer type, and we have discussed about this factor. Gender is a string value, female and male. 2 we have. So it's going to identify how many unique values are available. Only 2 unique values are available. That's why it is showing that the levels are only 2. 2 levels, that is female and male. And what R will do, it's going to convert the values into numerical values. Here 2 says that male and 1 says that female, or vice versa. So here male and female both have given numbers 1 and 2. So wherever the male comes, it's going to represent it as 1, and wherever female comes, it's going to represent it as 2. If you have more than 2 or 3, it's going to give that levels 1, 2, 3, 4. Like this, the factoring is going to work. What is the advantage of this one? You are going to see that one. If you want to count the female and male, if you sum up these values, these ones, you are going to get the value of that count. Based on that, you can able to easily identify the count of the values. You can mention or you can represent these values in the form of a table. You are going to see that. And rest of other data types also integer. So here, while doing this data analysis, first we have to load the data. After loading that, we have to see the structure of the data. The structure is going to give us much information. And we have already learned that how this head function and tail function works. Head function is going to return us a first 6 values, and the tail is going to return last 6 values or 6 records. Head is going to return first 6 records and tail is going to return last 6 records. So here we can see why we are going to see this head and tail in the sense to check that whether the records have loaded properly or not. If first few records and last few records are loaded properly, then we can assume that all the data set is loaded properly. We have another interesting function, that is summary. Summary. We have learned one function is str, that is structure. We can understand the structure of the data frame. Now here we wanted to check the summary, and this summary is going to return us 5 important statistical values. Those are minimum value, first quartile, median, mean, third quartile and maximum. I'd like to write those values. We are going to get minimum value, first quartile, and we are going to get median, third quartile, and finally we are going to get the max value. 5 important statistical values. By this, what we can understand is that what is the minimum value in that column? What is the minimum value in that column? And what is the max value in that column? And median is going to give us what is the center value. And this first quartile and third quartile will give us that what is the mid value between this mean and median and max. This mean and median center value is going to be first quartile, and median and max center value is going to be third quartile. We are going to get 5 values. The 5 values summary we are going to talk. We are going to call about this one. So this is how it is going to give. We'll see that what it is going to give. See this age. What is the minimum age of the customer? It is shown. So it is showing that 18 is the minimum age. And what is the maximum age? It is the 70. Here, if we consider the column name as age, so the minimum age is 18 and the maximum age of the customer is 70. So, with the help of this summary, as a gist, we are going to get what is the short value and what is the large value. What is the small value, what is the large value. By seeing these two values, we can come to some conclusion that which age group of people are visiting our shop. Here it is showing that 18 to 70 people are coming, 18 age to 70 age people are visiting our shop. One point we have understood by seeing this summary. Next, what is the average value kind of thing? What is the center value? The center value is 36. In the sense, the people are between 36 to 18 and 36 to 70 we are having. It is equally distributed. Very fine. And we can see that, okay, what is the center value between this 18 and 36? It is 28. So this 28 is very near to this 36 than the 18. So we can understand that the people more coming between 28 to 36 than the 18 to 26. This is an interesting one. So more teenage people are visiting. Okay? This is what we have understood. And rest is 49. And here we got another interesting statistical value is the mean. This is the average value. Okay. So, like this, we are going to get these statistical values, and you are going to learn these statistical values usage in data mining subject. So, if we see only one particular column summary, so here what I have done is that instead of passing the entire data frame, here I have passed only single column. And we know that to access a column, we are going to use a dollar symbol. So here I am using a data frame, and here I am using a column name. So data frame dollar column name. So only age summary we have got. So that is the minimum value and the first quartile, median, mean and third quartile and maximum value, which we have already seen. The same values we have got. And standard deviation. This is an important SD. An important characteristic in statistics, standard deviation. We assume that our data follows this normal distribution. This curve we are going to call it as a normal distribution. In the sense, whatever the set of values we have taken, those values are spread in a normalized or bell curve manner. What is the significance of this bell curve is, this mean value we are going to assume 0, and the length here and here is going to be same towards left and towards right. And the more space you are going to find in center only, near to this 0 or center point, mean value. And when you are passing to this levels, these edges, the value is going to be reduced. Means the people who are falling in this area is going to be limited. So more people are going to be in this portion of the value. And if you observe here, you can see this yellow value. This yellow is the maximum portion covered, and this next is the pink one, and finally this green part. Okay, this is going to be very limited persons. Okay. So we have this formula. Using this formula, we can able to compute this one. Actually, computing this one is related to the data mining or statistical thing. But here we need not to compute this one manually. We have a function called the SD. By using this SD, we can able to find out the answer. You'll see that. See this. SD stands for the standard deviation of customer age. So if you check out that one, you're going to get the output. So here we have seen another summary of the income data. So what is the minimum income and what is the maximum income? So in thousands, it's the 15,000 is the minimum income and 137,000 is the maximum income. Okay. And third quartile, median value, first quartile, you can observe, we have already discussed at this point. And standard deviation of the income, this is 26,000, that is 26.2 we got, standard deviation. And spending score, standard deviation. 25. Now here is an interesting function called the table. We are passing the column gender to this one. Gender we have passed. And we know that in gender we have only two values, that is female and male. So these are the two levels we have. And these two levels are, we wanted to show in a table format. We haven't done anything. We just kept that string as factors. String as factors equal to true. So in a column, if we have strings, it's going to convert them into factors. And once it has converted, it is going to give the unique value. It is going to find out how many unique strings are there. And each and every string is given one numerical value. So here we have seen that 1 and 2. So if I use this table function, it's going to give me in a table format that we have only two levels, that is female and male, and female count is 112 and male count is 88. So in a quick manner we can able to find out that how many records are there, how many groups are there in the data. So our customers are divided into two groups quickly, and we have got the count that 112 people are female and 88 are male. So with this we can identify that to our shop the more female customers are visiting than the male customers. So this is one insight, and we can take some decisions based on this insight. Now we are going to learn that how we are going to use the plots to visualize the data, and visualization gives us how better insights of the data. Though this visualization part is not covered in our syllabus, but this helps you to do some research work, or while you are writing any research papers, then these plots are going to be helpful to you. So here let's see a bar plot. So bar plot is a function. So to this function we have passed the data frame or the vector, okay, and we wanted to display that with the help of some values. That is, this is the title, using a bar plot to display the gender comparison. So we have passed the gender values, male and female, and we wanted to see that what is the count of male and what is the count of female in graphical format, and labels these two are X label and Y label. X label shows us the count and Y label shows us the count and X label shows us the gender. And color we can mention rainbow colors, and legends, the row names are going to be shown. Okay. And here this plus symbol is nothing but extending the command. Here we have extending our command with the help of the commas. So in R, the command extension is going to be shown with the help of this plus symbol. And if you see the output, you are going to see in this manner. Look this plot. This is X label and this is Y label. And these are the names, and this is the bar plot. So it shows that how many male values are there, female values are there. So by seeing this plot, we quickly understand that what is the level of the people. So female people are more. We can able to see in a simple manner. With the help of some pie chart, we will see that one. Okay. A pie chart, we are going to use some percentage, and using that one we are going to calculate, we are going to see that pie chart. Let us see this. So this is the pie chart in 3D format. So it is showing that in the form of percentage. So we have calculated that 112 and 88. We know that female people are 112 and male people are 88. And total we have 200. So in 200, what is the percentage of 112 and what is the percentage of 88 we have computed. And that value we have passed to this 3D one. And finally we have shown the graph in this format. The male is 44% and female is 56% with the colors. This is the pie chart. And in this pie chart, if you observe, we have used a function called the library. This library function is used to import the packages. Import the packages. In Java and Python, we are going to use a function called the import. But in R, we are going to use a function called the library. So this is a different point we have to remember. Using library function, we are going to load the packages in R programming. So how to draw a histogram? A histogram is similar to the bar plot, but some difference is there. Here you are going to observe the difference also. The histogram's length we can give, that we call it as a bucket size. So the data is going to be arranged into buckets, and in each bucket how many values we wanted to put we can mention. This is the difference between the bar plot and the histogram. Let us see here. The data we are giving age and X labels and Y labels, and labels are true. Basic information here we have given. Okay. And if you observe, this is the histogram of the count of age. So if you see, this is my age class, and here it shows that at the age 17 we have 15 people, at the age 21 we have more than 20, and with the age with the age 30 we have 36 people. So this is my age class and this is the frequency class. It shows that below 30 how many people are there, and at 30 how many people are there, and 30 to 70 how many people are there. And if you observe clearly, 60 to 70 we have 17 people. So exactly 60 to 65 only 5 people are there. In the sense, this age people frequency is very less. And which age people frequency is high? You observe, okay, 40 to 45, 45 to 50, this part. 45 to 50, this is 40 and this is 45, and 45 to 50 is 26 count is there. So the first highest age people are at age 30 and we have 36 people, and here 45 to 50 next is 26, and next is 24 and 24, that is 25 to 30. As I told you, this is going to tell us that 45 to 50 people are 26, and next people are 35 to 40. We have 24. So by this way we can able to understand the data, and this gives us much information for us. What this diagram shows us, in the age people 30 and 45 to 50, more people are coming. So we can take some decisions by considering this age group people. This is an interesting point. Let us see their income. So here we have used the histogram to analyze their income. So which income people are more? Okay. That income is kept in buckets. So this is buckets. 20,000 to 40,000 one bucket, 40 to 60 and 60 to 80, 80 to 100,000, 100,000 to 120 and 120 to 140,000. So we have taken a gap of 20, 20, 20,000. This is the bucket. So if you observe, below 20,000, 16 people are there, and more people are going to fall in the bucket 65 to 60 to 65 and 65 to 80. So 65,000 to 80,000. 36 people are there. Out of 200 people, 36 people are falling in this group. And next highest is 28, is 60 to 65. 60,000 to 65,000. Next highest group. So the customer's average salary is 60 to 65, 60 to 80,000 we can assume. So 36 plus 28, 50 and 64 people are there out of 12,200. So this is a good number of people which are falling in this range. So by keeping their income in our mind, we can launch the new waivers or new schemes so that we can attract more purchases. So this is what called the data analysis. This is the way we are going to analyze the data with the help of different plots and graphs. So we'll get some insights. These insights we cannot able to get by seeing the Excel sheet with the 200 records or 1,000, 2,000 records or 2 lakhs of records. But if you put them in a proper plot or a graph, you can able to get some meaningful information. This is what called the data analysis. Let us see some more plots. This is a density plot. Density tells us that at which area more people are falling. We have seen the histogram. Histogram is showing in the form of buckets, groups, whereas in density it's not going to have that discrete things. It's going to give us a smooth curve, another way of understanding the values. So this is how we are going to get the output. So here if you observe, the more values, more people are at central point, that is a median value of 50 to 60. And if the annual income if you take, as we have seen, okay, 50 to some around 70 or 75, the more people are there. This gives us an accurate picture, this density plot. And analyzing the spending score of the customers. So we are going to apply the same functions on different columns to analyze the data in different dimensions. Each and every column we can call it as a dimension. See, this is an interesting plot. We call it as box plot. We call it as box plot. This is the box. Okay. We can call this as also 5-point summary. 5-point summary. This 5-point summary gives us 5 points as we have seen it in the summary function. This is the minimum value and this is the median value and this is our maximum value and these two are the quartiles. This is first quartile and this is third quartile. That is the center point of this part and center point of this part. And this box plot gives us sometimes the outliers also. Outlier in the sense the values which are not falling even in this minimum range or even in this maximum value, which are out of this part. You are going to learn how to calculate these things in your data mining subject, but this plot is going to give us the outliers also. So let's come to the summary. In this session we have learned that what is data analysis and how a customer data can be analyzed. First we have learned how to load the data. Then with the help of the str function, how to visualize the structure of the data. And later we have seen the summary. This summary is going to give us the 6 points, that is minimum value, first quartile, and median value, mean value, third quartile, and lastly maximum value. As 6 important statistical values it is going to return. And how to access the data column by column. With the help of a dollar symbol we can able to access this one. And various statistical operations, that is standard deviation and etc. And finally how we can use the different charts and plots to analyze the data. Thank you for watching.